Hello everyone, this week we are looking at something called specific heat capacity. We've actually done this topic before. It's in P1. I think we did it all the way back in September. You might have forgotten about it. We did a required practical about it, but we're going to use this week's lesson just to kind of recap it and make sure we know what is going on. So we're going to look at what it is, and we're going to have a look at how we use the equation to calculate specific heat capacity. So for this lesson you will need a piece of paper and a pen and a calculator. So first of all, if you go to McDonald's and you buy an apple pie, it's always really hot, and if you're really excited to eat it, then it will burn your mouth. Why does that happen? Well, the reason is because in the apple pie there is lots of sugar, and the apple pie mixture inside gets very hot, and it stays hot for a very long time. And this is all to do with something called specific heat capacity. Another example is if you're at the beach and it's a really sunny day. By the end of the day, the sand gets pretty hot, it's heated up by the sun, but the water stays cold, so it doesn't heat up as much. Why does that happen? They're receiving the same amount of heat energy, but the water, the temperature might go up a little bit, but the sand gets a lot hotter. Why does that happen? And that's because putting the same amount of heat into some materials gives them a bigger temperature rise than in other materials, and this depends on something called their specific heat capacity. So for example, if we think about water, to increase the temperature of a kilogram of water by 1 degree C, we need 4,200 joules of energy. So you measure out a kilogram of water, you want to heat it up just by 1 degree C, so to maybe go from 20 degrees C to 21 degrees C, that needs 4,200 joules of energy. But if you have a lump of copper, which is a metal, the same mass, 1 kilogram of it, and you also want to increase the temperature of that by 1 degree C, that only needs 390 joules of energy. So it needs a lot less energy to heat up copper than it does for water. And that is because they have different specific heat capacities. And the specific heat capacity, or SHC, is the amount of energy that's needed to increase the temperature of 1 kilogram of a material by 1 degree C. That's quite an important definition. You might want to pause the video and write that one down just so you've got it. We'll also look at the equation in a second. So the amount of energy that's needed to increase the temperature of 1 kilogram of a material by 1 degree C. So the amount of energy required to heat up water, a kilogram of water by 1 degree C, or the kilogram of copper, or a kilogram of sand, or any kind of material, a kilogram of McDonald's apple pie maybe. So from this we can tell that the specific heat capacity for water is 4,200 joules per kilogram degree C. That's the unit for specific heat capacity. And for copper it's 390 joules per kilogram degree C. And we can use this to work out how much energy is needed to raise the temperature of a material by a certain amount. We have used this equation before, you might have forgotten it, and that's fine. I'd like you just to write this one down. So energy equals mass times specific heat capacity times the temperature change of an object. We measure energy in joules, mass in kilograms, the temperature change is measured in degrees C, and specific heat capacity is measured in this fun unit, joules per kilogram degree C. So I'd say pause the video, write this one down because you'll need it in this lesson as well as the unit. So once you've done that, press play again. Okay, so hopefully you've got that one written down. So let's look at an example of using this equation. How much energy is needed to increase the temperature of 600 grams of water by 80 degrees C in a kettle? Now just make sure the mass there is given in grams. If you remember earlier, I said that the mass is measured in kilograms. So 600 grams is the same as 0.6 kilograms. And you'll always be told the specific heat capacity. So it says here, the specific heat capacity of water is 4,200 joules per kilogram degree C. So to work out the energy, it's the mass times the specific heat capacity times the temperature change. All that information is given to you in the question. So in the question it says the mass is 0.6 kilograms. It says the specific heat capacity is 4,200 joules per kilogram degree C. And the temperature change, it's saying it needs to increase it by 80 degrees, so it would be 80. Sometimes it's worth underlining the numbers that you see in the equation, in the questions that you're given, because that'll make it easier to actually pick out which ones you need. So if we do this equation, then 0.6 times 4,200 times 80, it will give you an answer of 201,600 joules. Often these numbers are really big, and that's fine. If you get a big number, don't think you've done it wrong. The numbers for specific capacity are quite big. So before I get you to do some example questions, if we just go back to think about our sand and the water, what we can now know is that water has got a bigger specific heat capacity than sand. So it needs more heat energy to heat up water, or more energy to heat up water than it is to heat up sand. So that's why sand gets hotter quicker compared to the water. So what I'd like you to do now is have a go at answering these 4 questions. So you need to calculate the energy needed to, first of all, raise the temperature of 0.20 kilograms of aluminium from 15 degrees C to 40 degrees C. So for this one, you need to know the mass. There's your mass. You need to know the specific heat capacity, and that's given to you up here. So for water, if it's asking about water, the specific heat capacity is 4,200. If it's asking you about aluminium, the specific heat capacity for that is 900. The temperature change, well, it's going from 15 to 40, so you have to work out the difference between those numbers. So that's going to be 25 degrees C, the difference between those. So it'll be 0.2 times 900 for aluminium times 25. Question 2, raising the temperature of 0.4 kilograms of water from 15 to 40 degrees C. And for this one, raise the temperature of 0.4 kilograms of water in an aluminium container of mass 0.2 kilograms from 15 degrees C to 40 degrees C. So in this question, we've got 2 things. We've got the water, first of all. So work out 0.4 kilograms of water going from 15 to 40. And then you've got the actual container that gets hotter as well. So it's in an aluminium container. So there's your mass. And then you add those 2 numbers together. And then see if you can answer question 4. A small bucket of water and a large bucket of water are left in strong sunlight. Which warms up faster? And give a reason for your answer. So pause your video, get your calculator out, see if you can answer these 4, and we'll go through the answers in a second. Don't just keep watching the video and just wait for me to tell you the answers, because that's cheating. And I'd like you to have a go at these at least, even if you're not 100% sure, have a go at it, and then we'll have a look at what your answers are. Okay, so for question 1, 0.2 times 900 times 25, your answer should be 4,500 joules, 4500. For question 2, for this one, it'll be 0.4 times 4,200 times 25, and your answer is 42,000 joules, so 42000. For question 3, your answer should be 46,500 joules. You add the 2 together, so 46500 is your answer for that one. Sorry. And for question 4, which warms up faster? It should be the small bucket. That will warm up faster than the large bucket, and the reason is because it has a smaller mass. It has a lower mass, and so it will get hotter quicker. So what I'd like you to do now for this lesson is 2 things. First of all, if you have a look on Google Classroom, there is something called the Specific Heat Capacity Quiz. 4 multiple choice questions I'd like you to have a go at and submitting your answers, and it will mark it straight away. Just be careful for this question here. What's the correct formula for calculating specific heat capacity? You will need to rearrange the equation that we looked at earlier, so you need to rearrange it for that one. And the second thing I'd like you to do is this sheet. Just a few questions on here. You need to do the warm-up, fill in the table, answer this question and answer this one here, and then submit your answers to this sheet. You don't have to print out the sheet and write the answers on it if you don't want to. If you haven't got a printer, I'm happy if you just write out the answers in order and submit them on Google Classroom, or if you just want to type them out and send them on Google Classroom, either of those is fine. So do this sheet and do the quiz. Good luck. Any questions, let me know.